Hi everyone! Today's video lesson is going to review some exponent rules. Okay, let's first have a discussion about when we add or subtract terms with the same exponent. These terms are called like terms, so we can only add the terms together if their exponents are the same. Which terms in this problem do you see that have the same exponent? If you said the first term and the last term, then you are absolutely correct. This is x cubed, and this is also x cubed. That means I can add them together. So we will only add like terms. When we are adding or subtracting like terms, the exponent stays the same. X to the third and x to the third, when I add them together, it's still x to the third. What changes is the coefficients that are in front of those terms. The sign here stays with the coefficient. So here I have a positive 2, x cubed. Now, what is the coefficient in front of here? Well, if you don't see a number there, it's not a 0, it's a 1. There's only one of these terms. If it was a 0 in front, you wouldn't see a term at all. So, make sure that you are adding 1 x cubed to the other like term, which is 2x cubed. Now, when we add our coefficients, 1 plus 2 is obviously 3. So our like terms combined become 3x cubed. We add or subtract only the coefficients. So what do we do with this term that has no like terms? Since I can't combine this term with any other like terms, you bring it down the way that it is. This makes our final addition of these terms 3x cubed minus 1x squared. Okay, now that we've gone through some examples together, it's your turn to try some problems. Please pause the video and complete these problems on your own. Remember, the only way to learn math is by doing it. It's okay to make mistakes as long as you're trying. Once you're done, unpause the video and I will go over the problems with you. Remember, if you have any questions, to make note so that we can talk about this through email, Remind, or during office hours. Thank you for taking the time to practice these problems on your own. So, as you can see, we do have a term, or two binomials that are inside sets of parentheses. The numbers in front need to be distributed inside. However, they're both positive 1. If you multiply anything by positive 1, it doesn't change. So 1 times 5p squared, 1 times negative 3, plus 1 times 2p squared, and 1 times negative 3p cubed. So essentially, if you have a positive 1 here, you really can just ignore all of the parentheses. It's when there's a negative number or a number that's not 1 when distribution becomes really important. Now that I've rewritten it without parentheses, let's examine the like terms. Which terms do you see that are like in this problem? Here is 5p squared, and then a positive 2p squared. Those terms are alike because p squared and p squared are both to the exponent of 2. So these terms will be added together. Add the coefficients, not the exponents. Positive 5 and positive 2 give you 7 times p squared. The other term with a variable is negative 3p cubed. Do you see any other p cubes? Since there aren't, we bring this term down as is. This also applies to our negative 3. This is the only constant, meaning term without a variable, so it will also come down as is. Writing it in standard form, we write the terms from greatest exponent to least exponent. The greatest exponent here is p cubed. So our negative 3 p cubed will come first. The second highest exponent is p squared. Remember, that's a positive 7 p squared. And the constant is our last term, which is negative 3. Looking at our second example, we can see that there are two binomials in parentheses. However, do you see that there is a negative 1? Our next example involves two binomials inside of parentheses again. However, this time you see that there's a negative in front of the second set of parentheses. Since there is no visible coefficient here, it's a negative 1. And as we discussed before, that means I will be distributing a negative 1 to each term inside this set of parentheses, essentially changing their signs. No coefficient is in front of here, so the first set will remain as is. 4r cubed plus 3r to the fourth. This is where we distribute our negative. Since this was a positive r to the fourth, and I'm multiplying it by negative 1, it's negative r to the fourth. Here I'm multiplying negative 1 by negative 5r cubed. A negative times a negative becomes a positive, and this is why all of the signs will change. So, having completed my distribution and removed the parentheses, I'm left with 4r cubed plus 3r to the fourth minus 1r to the fourth plus 5r cubed. We can now examine the sets of like terms. I like to start with the term with the highest exponent, which makes it easier for me to write my final answer in standard form. We have an r to the fourth here, 3r to the fourth, and negative 1r to the fourth. Combining the coefficients, not changing the exponents, 3r to the fourth minus 1r to the fourth becomes 2r to the fourth. I do have another set of like terms. 4r cubed plus 5r cubed. They are both positive. So these coefficients will be added together. I have positive 4 and positive 5, which makes positive 9r cubed. How are you doing so far? Please, if you're having any questions or concerns, remember to take note and we can discuss it at a later time. In our third example, we also see two binomials in parentheses with a negative 1 in the middle. So once again, we will be distributing negative 1 to each of these terms, which will result in a change of sign. bring down your first two terms, 3x to the fourth minus 3x. Now negative 1 times positive 3x becomes negative 3x, and negative 1 times negative 3x to the fourth. Negative 1 times negative 1 changes this to a positive 3x to the fourth. Let's examine our like terms. Going from highest exponents, here is a 3x to the fourth and another 3x to the fourth, the coefficient in front being positive. 3x to the fourth plus 3x to the fourth becomes 6x to the fourth. For my x's to the power of 1, negative 3x minus 3x. Be careful when you are combining two negative numbers. If I take negative 3x and take 3 away from that, it actually becomes Now be careful when adding two negative numbers together. Think about a number line. If I have negative 3, and then I take 3 away, 3 negative, be careful when adding negative numbers. If it helps you to picture this on a number line, feel free to do so. I am starting with a negative 3, and then I'm taking 3 away from that, or 3 in the left direction. So negative 3 and negative 3 becomes a negative 6x. You can also think of this as adding the numbers together and keeping it negative. Now that all my like terms are combined, I will write my final answer in standard form, 6x to the fourth minus 6x. So as we look at the fourth problem, we see that there are terms that are inside parentheses. But remember, if there's a positive 1 in front of each set, then the parentheses, then nothing inside the parentheses will change because everything is simply being multiplied by 1. So bring down all your terms without the parentheses. Negative 7x to the fifth plus 14 minus 2x plus 10x to the fourth plus 7x plus 5x squared. Let's look at the term with the highest exponent. This is x to the fifth. Looking at the other terms, we have x to the first, to the fourth, to the first, and to the second. None of these other terms are like terms with negative 7x to the fifth, so that will be brought down as is. 10x to the fourth is the next term in ascending. 10x to the fourth is the next term in descending powers. There is no other x to the fourth, so once again, bring this down with the sign. 5x squared is also a term without like terms, so I bring that down as well. the next exponent in terms of standard form is x to the first power. This is the only case in this problem where I have like terms. So negative 2x to the first plus 7x to the first. Well, if we have negative 2 plus 7, which is equivalent to 7 minus 2, because addition is commutative, or it doesn't matter which order you perform it in, we get 5x to the first. Finally, we have a constant of 14. No other like terms there, so that is simply added on the end. Rewriting in standard form our final answer, negative 7x to the fifth plus 10x to the fourth plus 5x squared plus 5x plus 14. So how did you do? I hope this clarified some of your misconceptions and was a good review for the topics coming up. Next, we're going to talk about multiplication of terms with exponents.